Welcome to class for today. We're going to be looking at a review on polygons and related topics. So just hang on there. I'm going to admit my student into the class right away. And when at the end of the class, if you like what you watch, please subscribe to the channel. Thank you. So this is just the introductory part of this review and trying to state some of the things that we've learned. Introduction to geometry terms, about lines, about rays, about angles and circles. Um, we also learn about different polygons and their names, such as hexagon, nonagon, and so on. Then we explore two types of polygons, triangles, quadrilateral more closely. We found that there were several types of each figure, and based on size and angle. Then we switch from two-dimensional figures to three-dimensional figures. Then we studied the solid figures, and we also discovered that there were several attributes of solid figures in common with plane figures, such as the vertices and the sides. We also learned about prisms and pyramids, cylinders, cones, and spheres. We went back to two dimension and learned about congruent, that is, equal shapes and similar figures. So we explored this in the coordinate plane, where we also looked at transformation. So he's trying to record now. Let me see.
Hello.
Okay. How are you, Mickey?
Recording in progress.
All right. All right. You're welcome to class for today. So we have a review, but have you done your project, Mickey? Are you there? Okay. I think he's not there right now. So we looked at transformations that cut across translation, reflection, and rotations. And they all produce congruent, which are equal figures. And
Yeah, I
finally,
go toilets.
okay, Duke, we can come back, Duke. And finally, we explore symmetry and found that some figures have lines, symmetry, and or rotational or point symmetry. And these types of symmetry were similar to reflections and rotations. So we can move on by saying we need to learn the use of geometry terms. To review them, identify parts of a circle, to measure and classify angles, to name and classify types of polygon, to name and classify solid figures and identify nets of shapes, then to identify similar and congruent figures of transformation and symmetry. So the basic terms here: line of symmetry, the line which divides a figure into two congruent mirror images. Line symmetry is a property where a figure can be folded along the line to
Go back
create
now.
two congruent. So are you there now? Okay,
Yeah, yeah.
I want you to read this for me.
Line of symmetry. Line of the original images. Line symmetry. Property before the mirror images.
Me,
Additional
Maggie.
symmetry or point symmetry property that allows a figure to be rotated less
Miggy,
300
Miggy, I know you can do
centimeters.
better than that. I know. I'm very
Symmetry says
certain.
hello. The
Hmm.
same also referred to as point symmetry.
I know you can read it very well, but I know you can choose to read it anyhow you want to read it. Hmm? Is that correct?
Yeah. 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 Yeah.
Uh-huh. So, line of symmetry, that's a line which divides figures into two congruent mirror images, that is, images that are similar, okay,
Yeah. Yeah.
and that
Fine.
are equal. So, line symmetry is a property where a figure can be folded alongside and it creates two congruent mirror images equal to one another. Then, rotational symmetry or point symmetry is a property that allows a figure to be rotated less than 360 degrees and still look the same like the original figure. So also referred to as point symmetry. That's rotational symmetry. Okay, let's go to the next session and see what we've got there. Here we're talking about a circle, and we know that we have ray, then we have lines. If there's one direction on the line, the line segment, it's a ray. If it has no direction at all, no arrow direction, no point direction, then it's just a line segment. And if it has 2 point direction, that is a full line, just a line. So um, in a circle, part of a circle, we found the diameter is twice of the radius. So if radius is 3, diameter is 6. If radius is 6.5, diameter is 13. Okay.
Yeah.
So diameter is twice of, and we have chord. Chord touches two opposite sides of a circle but doesn't go through the center. But diameter touches two opposite sides of a circle but goes through the center, while radius sweep from the center of circle all around the circumference. So, and we see that protractor can be used to measure angles and so on. And we can see acute angles from 0 but less than 90, uh, greater than 0 but less than 90. Right angle must be 90, and obtuse angle must be greater than 90 and less than 180, while straight angle is 180. So we can see all of these in this shape here, okay?
Yes.
So let's go to the next page. Then we can look at several polygons. If a polygon has 3 sides, it's a triangle, that's 3 angles. 4 sides, a quadrilateral, that's 4 angles. 5 sides, a pentagon, that's 5 angles. 6 side is hexagon, that's 6 angles. 7 side is heptagon, that's 7 angles. Eight side is octagon, that's 8 angles. 9 sides is nonagon, that's 9 angles there. 10 sides is decagon, that's 10 angles. Then dodecagon, that is 2 and 10, that is 12. So dodecagon has 12 angles. Then if we have anything that's greater than that, we just call it maybe 13 gon, 14 gon, 40 gon, 100 gon, based on the number of sides. We also look at all of uh, the polygons. We can see triangle. We can see uh, square. We can see this is a pentagon. Then we can say this is a scaling triangle because none of the sides are equal, and none of the angles are equal. This is an isosceles triangle because the base angles are equal and 2 sides are equal. Then this is an equilateral triangle because all the sides are equal, then all the angles are equal. This is an acute angle triangle simply because it has all of the angles less than 90 degrees. And this is an obtuse angle triangle because one of its angles greater than 90, while this is a right angle because um, one of the angle is 90 degree. Okay, just hold on a little bit. Miggy, can you hear me now? Oh, you are muted, so I mean you are muted, so I can hear you.
Oh, yes. Okay.
Okay. So now, did you read all of these names? Did you read all the shapes?
Yeah.
Okay, okay, no problem. Let's see. One look at example. So, what type of triangle is shown below? Yeah, and so this triangle. So we look at the attributes of triangle. So the triangle has an obtuse angle. You can see there. So it's an obtuse triangle. It's also a scaling triangle because none of the sides are equal. None of the sides are congruent. So it is scaling obtuse. Now, if we look at this, quadrilaterals were also classified by sides and angles. So we look at whether quadrilateral are parallel sides or congruent sides, and whether they are right angles or not. So we found that different quadrilaterals fit in different categories. Like this one, all of them are quadrilateral. Then trapezoid and isosceles trapezoid, they are both trapezoid. Then the rhombus, the parallelogram, rectangle, and square, they are all parallelograms. But then there's a parallelogram with the name parallelogram, while rhombus has the name rhombus, and rectangle has the name rectangle as a parallelogram. Square also has that. So you can see that a square is a quadrilateral, a parallelogram, a rectangle, and a rhombus. Is that clear?
Yes.
Then we have what type of quadrilateral is shown below. Of course, this is the sides are parallel. So we look at it because this figure is a parallelogram because opposite sides are parallel, and all of the sides are the same length. And we call it a rhombus because all the sides are the same. So we can see next we look at three-dimensional. We look at three-dimensional figures called solid figures. We found that prisms and pyramids have edges, faces, and vertices. So the edges are the side or the lines. The vertices are the points where the lines meet, and the faces are the planes. So then we can look at the net of some of the shapes. Prisms and pyramid also have nets, can open them up and see how they are made of, how they're made of. Then we also look at three-dimensional figures that have curved surface because of these, they don't have edges. Three-dimensional figures don't have edges, don't have faces, they just have curved surface. Okay. Is that clear?
Yeah.
Okay, now. So I want you to read what's in this, the number of edges, name the figure, name the edges, and name the vertices. Okay?
Yes.
Now name them now. Let me see. Yes, read them up. Let me hear you. Miggy, read everything on the table. You're losing focus. You're not concentrating, Miggy. Read everything on this table with me. Yes, I'm waiting.
Okay. Triangular pyramid 6, rectangular prism 12, triangular prism 9, 5, 6, 7, 12.
No, don't just give me 9, 5, 6. Say 9 edges, 5 faces, and 6 vertices for triangular prism. Okay, now start again. Yes. I'm waiting. I'm waiting. Read everything. Yes, Miggy? Yeah.
Yeah.
Read it, read it, read it, read it, okay?
What one?
Triangular prism, 9 edges, 5 faces, and 5 vertices. Read.
It is 12 faces, 6 vertices, 8.
Yes?
Oh yeah.
Yeah, read everything. I'm waiting. Read everything. Concentrate. Yes?
6.
Triangular prism has 9 edges, 5 faces, and 6 vertices. Read everything. Rectangular prism. Read it. Yes, I'm waiting.
Triangular prism.
So it has what?
4, 5, 6, 4, and 4.
Miggy,
Triangular,
mention the
triangular
what
prism
is
is just
4?
9.
What is 4?
Faces,
What is
5,
5? Mention it.
vertices, 6.
Miggy, read it properly. Triangular prism has 9 edges, 5 faces, 6 vertices. Let me hear that. Yes? Miggy, you're not responding. Miggy, do you know you're wasting time? Read everything on the table for me. Let me move it to the board so that your attention can be there. I'm going to move it to the board now, okay?
Oh yes.
Or you can read it without moving it to the board. Can you see it on the board now? Yes? Read everything on the board now.
Yes,
Concentrate.
I am reading. Triangular prism is just 9. Faces, 5, vertices, 6. Rectangular prism is just 12. Faces, 6, vertices, 8. Triangular pyramid is just 9. Faces, 5, vertices, 4. Circle is just 8. Faces, 5, vertices, 5. Then the range of 0. Faces, 7, vertices, 0. The whole is just 12. Faces, 1, vertices, vertices, 0. Period 0. It just faces 0. Vertices, 0.
Miggy,
0.
Miggy, what have you just done? What did you just do there now? Eh? I can't really even hear what you're saying. Hmm?
Yeah.
Okay. Let me ask you a question. How many faces has a square pyramid? Miggy, how many faces has a square pyramid?
Uh,
Yeah? How many faces has a square pyramid?
uh,
Yes, Mickey.
Square pyramid.
How many faces has a square pyramid? Yes. Answer the question. Check the table for your answer. Yes. Yes, yes, yes. Answer this question, Miggy. Answer this question. Read the question for me. Yes. I'm waiting. I'm waiting. You're wasting time. Miggy, how many faces has a square pyramid? Miggy,
Yes.
how many faces? Check the table. How many faces has a square pyramid? Look for square pyramid and tell me the number of faces. Okay.
Yeah.
How many faces has a square pyramid? Read the question. Yes.
Yeah.
You're not reading. Read the question, Miggy. Read this question.
How many faces? The square pyramid.
Now, look at the answer from the table and tell me the answer. Yes. Check the answer from the table. Miggy, what's the answer?
Uh,
Yes. I'm waiting.
yeah.
What's the answer? Check it from the table.
Yeah. Rectangular prism. The eight.
It's
I
not
mean
eight.
five.
Five. Now you're talking. So the next one that I'm going to ask you, how many vertices has a rectangular prism? Miggy, answer. How many vertices has a rectangular prism? Miggy,
Yeah.
how many vertices has a rectangular prism? Yes. Check the table and provide the answer. How many vertices has a rectangular prism? Yes. Check the table and provide the answer is right there, Miggy.
I think it's five.
How many vertices As a rectangular prism.
Side.
No, vertices, not faces. Rectangular prism. Look for rectangular prism and check the answer. Not square pyramid. You are checking square pyramid, you are telling me 5. Go for rectangular prism and check the number of vertices. Miggy,
Yes.
look at it
There
now.
are 5 faces of square pyramid.
I said rectangular prism, not square pyramid. Rectangular prism.
A,
How many vertices?
a,
8. Right?
yeah,
So I'm going to ask you another one. You need to concentrate. How many? Let's see. Okay, just make sure you concentrate. Okay. Okay.
yeah,
So the next page, we have seen similar figures and congruent figures. Similar figures, these ones are congruent because all of the sides are equal and all of the angles are equal. And we have seen this is translation because it moves from left to right without changing the direction of the vertices. Then this is rotation because the vertices are okay. This is reflection because it's reflected in a mirror. It's still the same thing, okay? Is that clear? But the B that's at the front, at the back is now at
yeah.
the front. The C that's at the front is now at the back, but the A doesn't change. Why this one is a rotation? Because it actually changed all of the dimensions to another spot. Okay. This one, GB, BD, this is reflection because it's just reflected the image. Then line symmetry or line of symmetry, where you divide the page, the image, and it gives you similar or congruent shape. So let's try to work on this page, okay? Is that clearer? Can you hear me? So a parallel with 4 right angles. What's a parallel that has a parallelogram that has 4 right angles? Okay, we can take rectangle, okay?
Yeah.
Rectangle. So the next one says a parallelogram with 4 congruent sides. Yeah, rectangle also has, okay, it's a square that has 4 congruent sides, but we can talk about rhombus too, okay? Because this doesn't take, so that's rhombus. Is that clear? Can you hear me?
Yeah.
Good. Having exactly the same size and shape, that is congruent, okay? It says something is congruent. Are you getting that? Congruent. Ent. E-N-T. Then, Miggy, are you following this?
Yeah.
Read this for me, Miggy.
Close figure made out of 9 segments.
That's polygon. Okay?
Yeah.
That's what?
Polygon.
Yeah. The next one, read it. A figure with all of its points in the same direction from center. That's a circle. That's a what?
Circle.
Circle. So always put all of these things in your mind. Then look at this one. A plane figure that one side is a solid figure. A plane figure that one side is a solid figure. Well, let's see. What do we call this one? That's a face, okay? Then a quadrilateral with two sets of parallel sides. A quadrilateral with two sets of so that should be parallelogram, okay? Is that clear? Okay. Miggy, you're not responding.
Yeah.
Then a polygon with six sides is called what? You know, I asked you to read it the other time. A polygon with six sides is called what? Miggy, you're not responding. A three-dimensional figure with circular base, that's called what? That's called what? Hold on. Then a shape or object that has been transformed. Okay, we can talk about image, okay? Is that clear? Miggy, you are not answering. Is that clear?
Yeah.
Okay. So now we want to end this section and move to the questions, okay? So next is to work on questions, right? Right, Miggy? Miggy, read all these.
Yeah.
Which answer will you pick for this? Yes, Miggy? Yes? Miggy, are you sleeping? Should we end the class for today?
Symmetry. The line I said symmetry. I said line symmetry.
Line symmetry is a property where a figure can be folded, so this is one. Then line of symmetry is a line that divides figure into two congruent images, that's two. While the point rotational symmetry is point symmetry, that's three, okay? Okay. What? Estimate the measure of this angle. Mingy, pick your option. Mingy, read the question and pick your option. I'm waiting.
The measure of the angle shown below.
So what's the answer? Yeah?
Estimate the measure of the angle shown below.
What's the answer? Hmm? Give me your answer. What do you think the angle measures? The angle is going to measure like 150 because it's not close to straight line, so it can be 170. Okay, the next page. What is the diameter? Miggy, what is 6.5 plus 6.5? Do this for me. I won't do this one for you. 6.5 plus 6.5. Miggy, what's the answer? Yes? Miggy, diameter is twice of radius. So 6.5 plus 6.5 is 13. Miggy, I want you to concentrate because you will write your test anytime soon and your exams, okay? Now, which of the following is not a line shown in the drawing? If we check line CE, CE in the drawing is not a line. AC in the drawing is a line. BE in the drawing is a line. DC is not a line but a ray. But since CE are not together, and we can pick two, so it's only one. Read this question for me. Miggy, are you there?
Yeah.
Read the question. I can't see
How
you there.
many
That's why
angles are there? How many angles does a nonagon have?
Yes, how many? What's the answer?
Fourth option.
Fourth option? No, it's third option. The fourth option is hexagon. Miggy, I can't see you there. Where are you? Let me see your face. Let me see you. Okay. Where are you? Miggy, don't waste time. We don't have time to waste, okay? Miggy, can you hear me? Hello? Okay, let me message your mom to check on you now because you've not been responding lately. Okay. Okay, so, um, Miggy, can you hear me?
Yeah. It's 9.
It's 9. I know it's 9. I told you it's 9. I want you to concentrate. Show me your face. Let me see you. So that we can round up, okay? Where are you? Did I put you in waiting room and had you again? Miggy? Did I put you in waiting room?
Fourth
You need to.
option.
It's the third option. I said, show your face. Where are you?
Yeah.
I can't see you there. That's what I'm
And you're
saying.
in a chair.
Yes, let me see your face.
Maybe the camera is too blurred.
No, it's not blurry. You are sleeping. I want to see your face. You think I don't know what you can do? You are sleeping already. So let me see your face now. Okay?
Yeah.
I'm waiting. Sit up, sit up, sit up, sit up. Let me see your face. Miggy?
I'm here.
Yeah, I can see you. Let me see you so that I will see you concentrating. Then, okay, read this question for me. You're concentrating. Yes? Uh-huh, now I can see you. Read the question for me, Miggy. Read the question. You're not even looking at the screen. Read it.
Yeah.
Yes,
What
read
is
the
the
question.
most the specific name of the figure shown
Yes.
below?
What's the option you pick?
So trapezoid.
It is trapezoid, not isosceles, because no two sides are equal. The two sides aren't equal. In an isosceles trapezoid, the non-parallel sides are going to be equal, but this time around, they are not equal. So it's just a trapezoid. Then the next question. Are you ready? Now, read this one for me. Yeah, read the question.
Girl.
Miggy.
Baby girl. Oh,
Yes, read
baby
the question. Let
girl.
me hear you. You are busy playing, right? Okay. Let me give you 2 minutes to play. Oh, yeah, continue playing. Do you still want to play? Hmm?
Okay.
Now read the question. Read the question.
Rachel lives in your house by patient.
Yeah, what's the answer? You know, I was asking you the other time. Okay, what's the answer? Yeah? Pick your answer. That is the square pyramid. What is the net? What net is shown? That should be a triangular prism, okay? Is that clear? What is the measure of angle F? Angle F, since they are similar, congruent shape, is 63.
Yes. Yes, I understand, sir.
Okay. Then find line AB. Line AB is there. So if 4 times 2 gives me 8, then 5 times 2 will give me 10.
No, 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 no,
From
no,
the
no, no,
smaller
no,
to
no,
the
no, no, no,
bigger
no,
one. What is no?
no, 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 please, please, please.
Yes, what transformation is shown below? You can see that all of the vertices have been changed. Definitely, it is rotation.
Yay, yay, yay. Okay.
Then this one
Because
says, which half figure below will combine with this half figure to form a figure with line symmetry? So it's this first one. If you combine, it's going to form, it's the same size. So this first option should go in there. Then what triangle has an angle greater than 90 and two congruent sides, two equal sides? So this will be isosceles, obtuse isosceles, okay, because it's greater than 90. Is that clear, Biggie?
yeah,
So let's turn it in and see what the score for this should be. What is the score for this?
100.
And that means you should always concentrate so that you can
Yeah,
always get
whatever. Yeah, fine.
Mickey. You're on your own. Okay, then. Uh,
Okay, yes, yes.
so what about your piano? Is it available now? Not? Why?
No.
Why? Then when are you going to finish your project? You remember that we've done the project before, right?
Yeah, yeah, yes, yes.
So when are you going to finish?
Which one, the project?
You are asking me. Look at this one that is already due.
Yes, yes, yes. I can finish it late. I can finish it tomorrow.
You know I sent it to your mom, right?
Yeah, yeah.
So you should finish it and upload it. And you know that today is when we have class tomorrow, so you should have done it before tomorrow, okay?
Yeah, yeah, yeah.
All right then. So that is where we're running up for today, Biggie, okay?
Yeah, yeah.
I think I should. Okay, so you can exit the class now, Biggie. Goodbye.
Okay, bye bye. Okay, all right.
See you tomorrow. So viewers, thank you very much for watching this. It has been a nice time having you on board, but all students cannot be the same. That's why you see the pattern of this lesson with my students. I can tell you he's a very brilliant student, but he's easily distracted. And when you ask a lot of things, what he knows, once his attention is divided, he will not be able to, answer. But I'm hopeful that he concentrates, the more and the more and more, and more so that he can get to place and on whatever he has to do. Okay, and this is an advice to teachers also out there. Don't lose hope and get tired of the students because every student have their own, area of, they have areas where they're good, but if you're not patient with them, you just write them off. And that's not a good thing to do as a teacher. Thank you very much. I am Ajibolo. Please subscribe to this channel and I'll see you some other time. Bye for now. Cheers.